Welcome to everyone who's here with us at this moment. This is Community Conversations, obviously, for NXOpen. This is our enablement session that occurs quarterly. So we'll be talking about some FAQs, some examples, and some Python tips and tricks today. My name is Taryn Blake. I am Community Engagement Program Manager for our PLM community at Siemens, and I'll be your host for this session. Today, again, we'll be exploring some FAQs, examples, Python tips, and tricks for NXOpen. So, as many of you know, our speaker for this session is Frederik Vanhee. He is an expert in structural analysis automation. He's got over 15 years of experience, Simcenter 3D and NXOpen. So he's developed advanced methodologies for ship and offshore structure design and created a widely adopted NXOpen automation library. So it's now available as the Python package nxopentse, if I'm pronouncing that correctly. So he's an independent developer, and Frederik focuses on building tools that streamline engineering workflows and make high-level automation accessible to a broader range of users. And so we know that Python is the most popular language right now. We appreciate him helping us with filling this information gap. So for today, he'll be taking folks through some of the frequently asked NXOpen questions, including some questions from last session. And he'll give a high-level walkthrough of some example applications, and then go through some Python tips for working with collections, IntelliSense, and enumerations. So as mentioned, he's live. He's going to take us through this and share his screen in several different places, and then we'll get to the Q&A before the hour is over. That is all for me talking, so feel free to still the screen, Frederik.
Like that. So like Taryn mentioned already, the agenda for today will be Q&A from last session, because it was the first session. I think there were a lot of questions on NXOpen and all that kind of stuff. So we went through the Q&A and all the questions from there, and I made a summary of the questions asked, and then we'll go through some of the answers. Then I will show some examples as inspiration of what you can do with NXOpen and some ideas. And then we'll finish off with some tips and tricks. A recurring question is how to get IntelliSense working in loops. I'll give some information also on enumerations and how you can actually display them without just the integer number, but the actual text. And also a short thing on how to use traditional UF functions in Python in NXOpen and the IntelliSense to go with that. Let's get started with the Q&A. So, like Taryn mentioned already, probably the most occurring question is, will the recordings be available? Yes, they will be available on the NX forum Friday evening, if I'm not mistaken, if I remember correctly. They'll be posted. So by next week, this recording should be available, and you can actually have a relook at it, or if you weren't present, you can have a look at it. Another question which came up quite often is, can we execute headless NX via Python, just as with other languages? Yes, you can. The principle is exactly the same. Run journal with your file, and this is, I hope this is a bit readable, but we will also share these slides afterwards, so you can also read those. Run journal.exe, the full path. Make sure to have quotes if you have spaces in your names. So the full path to your journal.py, followed by the arguments keyword, and then pass your arguments, which will then be passed on by NX to your journal. And this should just run fine. Is there console input similar to like IPython? No, not out of the box. It's not available. I did see somebody, but he was anonymous, who made something small available, but maybe that person can make himself known or get in touch with me. And then maybe in one of these sections one of the next sessions, we would be able to share his solution, maybe walk through it even. Yes, sorry, that should have been. So that's the person having reported he hacked something together using sockets. So maybe he recognized the text, and we'll see. Can we use traditional UF functions in Python? Yes, we can. I will give a short overview at the end in the tips and tricks. Keep going. Another popular topic was, can we use external packages like NumPy and requests, and tkinter also. So tkinter can be used with the internal Python NX already out of the box. NumPy requests can be accessed if you configure NX to look for the external interpreter. There's a document here. Don't bother copying this. The slides will be available, and then you can actually just click the link after that. This is this NX documentation where it explains how to configure NX to use the external interpreter, such then you can use packages like NumPy, pandas, requests, all that kind of stuff. On my Udemy Advanced, I also have it available in the free to view section. So if you go to Udemy, NXOpen Advanced, or look for my name, you should find an advanced course, and there I also walk you through all the settings, which is basically the same as the NX documentation. No much difference there. I'm also thinking maybe on the next session, we might do something with the external interpreter and see if we can use NumPy and other packages in some examples. Another one is GUI support, graphical user interface, which means that can we add menus and user interaction in our journals? We have a concept called, or at Siemens NX has a concept called block styler. It also supports Python. I've used it extensively myself, but you need an additional license. I do have to say, if you want to build a bit more complex menus than just asking the user for a number or a string, or select a very simple object, I believe that it's worth it to have a block styler license. Makes life a lot easier and nicer. There is limited support for input, output, and selection out of the box. Maybe that's also for one of the next upcoming events. And then if you don't want or can use block styler, you can build your own menus with tkinter. Again, it can be done. I still recommend block styler if you can. Especially people in larger companies, I think the cost of a block styler license does not outweigh the time you will have to spend trying to get your tkinter menus to work. Question on parallel processing. Not really, nothing to do with journaling, NXOpen, or Python, basically because NX is inherently still single-threaded. If there's some NX developers in here, please correct me if I'm wrong, or maybe you can add some context on this in the Q&A. So the stub files, which provide your what we call IntelliSense in your development environment, these are available from NX 24.06.12 onwards. But you need, when you install NX, you need to check the programming tools during installation of NX. Otherwise, they will not be available. And they are located under UJI base tier, which is your typically C program files, Siemens, your NX version, and under UGOpen Python stubs. If you do not see this UGOpen folder, it means that these program tools were not checked during installation, and you might have to edit the installation to make them work. People also asked for older versions on the community forum quite some time ago already. I think, well, the last one is 23.06, so it must have been close to 3 years. I did release some Python stubs for NX12, release 2023, Simcenter or NX 22.12, files are the same, and then also for 23.06. So people on really older versions can use these, or if you have access to a later version of NX, for example, 24.12, you could also use those stub files in NX12, for example. The downside is they will give you hints of functionality which is not available yet, or which wasn't available at the time in NX12. So especially if your releases are further apart, the support might not be exactly show what's in there. Questions on debugging. You can use debugging using the Python debugger, which is a terminal application. Web PDB is a bit more user-friendly. It's also explained in my advanced Python topics course how you can set up this Web PDB, but it's just basically as any other Python application would use it. Maybe also it's a topic for one of the future events, but I would give precedence to like using external packages and some user interface things. Personally, but that's a personal thing, I don't use debugging too much. In the past, I learned to use I didn't really know what I was doing, so I learned to use the listing window as my debugging window, and it's a habit which kind of stuck, so I'm still doing it. Lots of questions on IDE. Should we use VS Code, Visual Studio, PyCharm? I saw some more advanced or exotic versions as well. It's a personal choice. Use what you're most comfortable with, what you already know, maybe even, and which supports Python. And the stub files with the IntelliSense should be able to configure in any type of IDE. My preference is VS Code because I also once in a while do other languages than Python, and then I can stay in the same environment. I believe that PyCharm is also quite a good choice. That's pure Python. Python versions in NX. So each version of NX can have and almost has a different Python versions. It's not that important if you only run journals, because in essence, it's NX interpreting the Python code and running it. So the version is not really that important. You can see it by creating a small journal and printing sys.executable and sys.version to the listing window, and that will show the internal version that NX is using of Python. Very interesting topic, licenses for NXOpen Python. This is a quote from Jim Bernard I've used. So as long as you're not sharing code and you're not writing applications to be distributed, then you can just use it without a license. If you're going to share code and distribute code, you need an NXOpen author license for Python. Small side note is that while for the other packages like .NET, the distribution with like DLLs and executables is technically enforced, you need a license to be able to run those as a user. In Python, that's not the case because Python is a scripting language, but it is still a legal enforcement by Siemens. Distribution of the code itself, I just mentioned, Python does not compile, so there's no need to compile it or have a DLL. But that also means that you simply distribute your source code. So everybody would be able to read your code. There are some packages around there which can actually obfuscate, let's say, your source code if you would really want to share it, but it's never really a full protection against people reading your source code. And as a side note, completely not relevant to Python, but for users using .NET, and I think coming from Solid Edge, that NX does not require the user to do COM registration. You create the DLL, you compile the DLL, and from that moment on, it's going through the startup folder where it gets registered automatically by NX startup. So no complex registration of COM objects going on. Some questions on Teamcenter also. Unfortunately, I'm not that familiar or that well versed in Teamcenter. Basically, you need some additional login code so that your Python journal can actually connect to Teamcenter so that you can open, save, and close parts. That syntax is also slightly different, but it's not much more than just the file name, wherein standalone or what's the technical term? Can't even remember the technical term for a standalone NX working on your local system. You give it the file paths fully. When you're working with Teamcenter, you give a small different syntax on that file name. But the rest of the code is the same. And you can edit part attributes if they're already mapped to an NX model. So you can open the model, change attributes with NXOpen code as required, and then save the model again, and that will do the syncing with Teamcenter. That's about as much I can tell about Teamcenter. So maybe at some point also in one of the future sessions, I need to consult with some other people and see if we can do maybe a joint session on Teamcenter. Hold on, I was a bit too quick. I skipped one. Yeah. Small question on Linux support. NX is available to be run on OpenSUSE and Red Hat, and I believe that's with a T. Red Hat Enterprise, but these are only applications which do not do GUI, only batch. So there is no user interface. It's all from the command line. And one thing extra is that you need a separate license to run these instances on Linux in batch. And then questions about AI. I think the best tip I can give is that when you point the AI model to the Python stubs folder, that improves in performance quite a bit, because it actually can see from there what all the syntax is and use that. There were some people who did some retrieval augment, and not sure, I thought it was a retrieval augment, rack pipeline, where basically you create a view of all the documentation and add that into the model before you do your request. And sorry?
No, you're good.
I'm good. I thought somebody would comment on this, help me out here. I tried it once. I found that it wasn't performing well, but that's just a very limited test. So I think other people are happy with it. So I guess you could use it. But I found that pointing the LLM to the stub files is great. One caveat I would like to make is that AI is fantastic. It is a fantastic tool. But I think we could have also spent a lot more time having developed libraries and shared code, and then we would have gotten a much easier life to actually write Python script based on wrapper codes and functions that would be available. Anyways, that's my opinion. Next, I want to go to some examples I've done in the past, recently or a long time ago. Just for some general inspiration, like what can you do? Because there were some questions like, what can you do with NXOpen? And then the general answer is, well, almost everything you can do in the user interface, but what does that mean? So I divided them in a few topics. Let's say admin and bookkeeping. For example, read points from parts and assemblies, do some coordinate transformation, and then export it to a custom format, which can then be consumed by other reporting or other inputs, maybe even like CAD/CAM systems and so on. Converting historical title blocks and styles to a new format. You have some old drawings imported from either historically or from other software, which have been converted, and you will still want to apply some, let's say, the look and feel of your more modern and current settings. Cleanup, clearing all unused materials and constrained components of historical models again. Going through all your models and get the overall dimensions of sheet bodies in an assembly. So you have an assembly of a few hundred parts, and you need a reporting, or you need to use that information for other programs, you can, for example, get all the dimensions for each sheet or normal body and export them also to file in whatever format you need it to be. There was also a question on, I think, in the FAQs on could we use NXOpen and Python and FEA and Simcenter? Answer is yes. Here I have an example where I would read results from simulation, structural results on shell elements, reading the stresses. Then I augmented that with some panel that was for buckling, geometric information on panel lengths, different formats, that kind of stuff. That was for a marine environment. I think that might also be familiar or sound familiar to people in airspace, where you need to perform buckling on shell structures with stringers and stiffeners. And then I performed a pre-processing and a calculation, where the calculation does the actual buckling validation check against code. That was done in the cloud on multiple instances, which automatically scale. And then the results are fed back to a file, which can then be read by Simcenter and displayed like any other results. I've recently, I think, open sourced this pre-process and calculate part, and reading the results from simulation and rolling the results was already available in the NXOpen TSC library that Taryn mentioned at the beginning of the session. That's available on GitHub as well. Batch running then, that's a bit similar to bookkeeping, but here we had to actually open a part based on points in the model. We had to build some additional features, do some part intersections, get these intersection properties, and write all those back to a file. So also a bit admin batch processing. And then some miscellaneous, simple, more complex and fun projects. For example, there was a client who wanted to have an Excel table available on the drawing, but that table wasn't just a plain table. It had it was dynamic. Let's say it could be bigger or smaller. It had merged cells. They wanted also to show the colors on the drawing because the colors also had meaning. What we did there was, in fact, we embedded the Excel file itself into the part file and wrote a little journal with a button connected in NX. So the user could press the button, and if the Excel file was already embedded, it would actually export it, the embedded file, start Excel, so the user could make his changes that he needed. If the file wasn't embedded yet, the user would be requested to select an Excel file to be added, and then that Excel table would actually be, basically a screenshot would be taken and would be added to the drawing. That made it that all the information lived in the part, so also traceability was taken care of there. But sometimes it's just very simple journals from which you get feedback that they're used very well or very often and that people are very happy with them. For example, a simple UI to build an empty assembly structure. You would think like, okay, you could have an assembly structure and just copy it where you need it. But here we also wanted to add or remove at the time certain parts of the assembly structure. And we also had different departments which would need different structures with different names. So that was all taken care of here. Another one is easily color your body types in a part and assembly. CAD parts versus convergent parts, give those different colors and recognize those colors again, so you could easily change the colors. Interesting one was also to generate an assembly from all bodies in let's say a flat part. The user was aware that this is not, let's say, standard practice to create an assembly, but he still wanted it to work this way for, I think, for concept development. So in that assembly, in that part, would identify all the bodies, split them out into different parts, and build them out in an assembly together with an Excel file, so that the user could afterwards use the Excel file to actually update the names of all the parts, which would make it a lot easier. And then that would also then be loaded again into the assembly and would update all the names of the assembly. Some more miscellaneous things. Unfortunately, I'm not sure if I sent the email out, but I was a bit too late to get confirmation that I could actually use these parts. Voila, and I just got an email from Sjors, who said I can share these videos, so this is fantastic. Thank you, Sjors. And that is the OLVG hospital in Amsterdam. And they're a great team. They also presented at Realize Live Amsterdam last year on how they use NX and NXOpen in the day-to-day surgical area, let's say. Let me see if I can pull up the video. The first one is how to generate a center line, or we would use NXOpen Python to generate a center line on a long convergent body. That's the technical CAD part. In fact, it's a human bone. If all goes well, you should be able to see it. Let me double check. Yes, you can. So this is a recording of a STL scan. So basically the human bone is taken from a CT scan. That CT scan is analyzed, and this STL file from the images is generated, and that STL file is then imported in NX as a convergent body. And then we are using NXOpen to generate the center line of this bone, because I always thought, you know, a bone is straight, but it's definitely not straight. And what it does, you can see it quite here. It generates a bounding box, generates a set of planes, and then for each of those planes, we generate the intersection, the COG of the cross-section, and we basically put a spline through the body. So nothing too spectacular, but a cool application on how you can generate a center line in a human bone. Yeah, some more views of the center line. You can actually see that it, even though there's only like, I think about 10-ish planes created, you can see that the center line follows the bone structure quite well. That's one. What they also do is they use what they call surgical guides, and they use those for drilling assistance of the surgeon during surgery. Very technical. Let me see if I can pull up that video, the surgical guide. Yes. So on a human bone again, the technician would generate a curve where they would have the surgical guide positioned. Then they would select that curve with a small block styler style, all in Python UI. And then again, all the steps would be just simply automated, making it easier for the operator to generate the part. So here you see, I think, a combination of some implicit modeling, regeneration of surfaces. I would really have to look into the names again of everything. That's where we go. That's the second surface. We pass through it. And then we do what was it again? I would have to look it up. I'm sorry. It's a bit too quick. It just generated. We do a law extension on the curve again, so we actually can get a surgical guide, which is then later on 3D printed and actually used in surgery. And then you see these bodies, some technical things on the law extension, how it's working. I think I have another more simple example here. Again, that's the surgical guides. And then a very practical one is that on these surgical guides, you actually want to make sure during surgery that the doctor knows how to position the guide onto the bone, and not only that he knows, but mainly not to make mistakes. So you know what's lateral and dorsal, and the how to position that. And for that, we made a small feature, text on surface on a doubly curved surface. So I've used the demo here of a globe or a sphere, or we can generate text on. So basically on the sphere, you determine a few points, you draw a line on it, and then the script automatically generates the text on the surface. And then if you add that to the surgical guide, it gives a double check for the surgeon, and it gets printed onto it. So that's how you create text on a doubly curved surface, and the practical application for it. Yes, I would like to thank George and the OLVG Amsterdam for being able to show these examples. And then I will finish off with something we've been working on recently at Polymath. I've recently joined Polymath also as a founding member employee. And there we also have, I think I've prepared a demo also. Here we regenerate a part from other software into NX, so we can start using these models again and continue them in NX. That's the idea. So if I start the demo, we will import a model, in this case a gasket, which was generated in other commercial software. And then in NX, we regenerate the sketch and the extrudes also. Voila. So you get the sketch and the extrude. And it's like it's always been modeled in NX, so you can still modify the sketch dimensions. You can also modify the extrude thicknesses and so on. So that's the example. It's still under development, but I thought it was fun also to show as an example of things we do in NXOpen. Sorry. And I want to finish off with the examples, and the inspiration is that the only limit, I think, is your imagination. It's a bit fluffy, but I think it's true. So now I want to go into the tips and tricks. And I want to cover how to handle IntelliSense in loops, calling UF functions in Python, and a small thingy also on enumerations. I will switch to VS Code. IntelliSense loop, yes. Let me close these down. This is actually the code I had promised earlier to color some bodies randomly. But let's start with this bit of code. So if we want to obtain all bodies in our work parts, it's basically all bodies work part dot bodies. Nothing spectacular here. But what we see is that bodies is a body collection. So all bodies is also considered a body collection. And while this works, this first loop, we do get an error because it says like, well, body collection is not iterable. That's one, but that's okay. The second one is that journal identifier would have been unknown. Somehow it is working. So not sure what happened here. Let me go back to my settings. Using my stops. Let me disable these and use the Siemens stops instead. Yes. Always a downside of a live demo. Yes, so no, it's still working. Sometimes it happens that actually when you call define this body here on the journal identifier, and I don't think it has to do with the code in the back, that this body is not recognized as an nxopen.body, and you do not get the IntelliSense what you would want it to be. The solution then is not to type as a body collection. The solution is to do list comprehension with typing. So if you then define, let's say, all bodies 4, you define it with typing as a list of nxopen.body, and then you do a list comprehension of the bodies in the work part.bodies, then your body here will be recognized as a body, nxopen.body, within that list of nxopen.body, because you've clearly stated that in this case, it is a list of nxopen.body, and your journal identifier will work. I get some squiggly lines here because of the settings. Let me take my settings back and switch back for now to my stub files here. Voila, maybe that will also solve my issue. I'll save this. Oh, save this one. Yeah, sometimes this hasn't worked, but clearly it's working now. So I apologize for this bad example of making it happen. An alternative, I will just give the solutions anyway, is that if you get into this problem again, that bodies is not recognized as an nxopen.body, you can predefine the body you're using in the for loop as an nxopen.body, and then this IntelliSense will also know that this body in here is of type nxopen.body, and you can also then use your IntelliSense as a journal identifier again. And the final solution is in fact using wrapper functions. So if we create new functions in which we have the functionality available, and those functions are defined with an object or the object type that they return from the typing, then when you call these bodies, it will know that all bodies is a list of body, because that's how you typed the function to return. And from there on, actually all IntelliSense will work without any underlines whatsoever. So this could help. Now, if we show the output of this, basically we print the journal identifier of the body several times, and here we give the body, all faces in the body a random color. It also works on all bodies. So we collect all bodies, we then loop over all bodies, and for each body, get all the faces in the body. And then for each of those faces, we loop again, and we color that face with a random color between 1 and 216, which are the NX integer colors. So if we now then run this on this very simple part, IntelliSense loop, and that's been a bit too big. You can see that all bodies or all faces get a random color. We run it again. Yeah, we get new random colors. So at every time, each of these functions just gives the journal identifier. Where am I? It's a journal identifier which we print here. So all this code works. I just had the example here where IntelliSense would not work, but the code would still work. That's it, I think, for IntelliSense in loops. I will try to figure out why this did not work and add it to the presentation. Second topic, so those were the three. You can use list comprehension, predefine the loop variable, or use wrapper functions to get IntelliSense working in loops. When we look at calling UF functions in Python, we'll open this one. See here, this one can close. UF functions. In order to use UF functions, we want to import NXOpen and also nxopen.uf. Now, this nxopen.uf is not supported within the stub files provided by Siemens, but they are in the stub files which I have generated in the past. And since these UF functions don't change much, we could still use stub files generated for these UF functions. This is an example I took from nxopentse, by the way. That code is in there. So once we define the UF session, we could actually call this object and, for example, see that we have a modeling, and I'll come back to this in a minute. And then in modeling, we have these ask maskprops 3D, the function I'm using here. And maskprops 3D takes a list of tags for its objects, the number of objects, and then units density, and also on. So this is all in the documentation. What I would just like to point you at is that my IntelliSense files are actually generated from the .NET code, and in .NET, the name model of MODL is used. So when we go look at the .NET code here, let me open this. We see here the function ask maskprops 3D in the .NET reference guide. And if we go home, we see this modeling name appear. So that's where the name MODL comes from. When we go look in the Python documentation for that same function, which is here again, ask maskprops 3D. It's a wrapper for the same C++ function, I think. But here we see that in Python it's called modeling. So that's why when we want to call it in Python, we need to call modeling. So if we call MODL, we will get an error. Unfortunately, we do not have IntelliSense working with modeling. That assumes model, and I haven't really never bothered to update that, just so that you know. But in essence, this works. So this is the call to the UF function. We ask for the mask properties, and we get back a tuple in Python. What you will also see is that if you're seeing UF functions which return or which use pass by reference in .NET, they will return these variables as a tuple in Python, simply because Python does not know the concept of pass by reference. So that's how I think the NX developers solve this. Everything passed by reference will actually be returned in the tuple from the return function. And then everything passed by reference is no longer an argument in the function. So the best thing is actually to check Python documentation on that sense. So what does this function do? It again gets all the bodies and the parts. It's actually a function from NXOpentse and CAD. And then it gets all the faces and does a random color. And then for each of the bodies, it gets the body properties, prints the mass, and the full body property. And this class here handles also the printing. So if we save this and we run this in NX, we get, where are we? UF functions. Voila, run this. It is a bit small. Not sure if I can make it bigger. So we first print the mass, and then we print the full output of this mass 3D props class. So with surface area, center of mass, moments of inertia, and the whole shebang, all from a UF function. So in Python, you can also call UF functions like, where was it again? Sorry, this one. You can also call UF functions like ask maskprop DD and all the other ones. So that just works fine. One thing I wanted to show you here is also that, again, the benefit of, because I copied these functions in, total length of our, let's say, very simple journal is about 200 lines. if we just simply import all that functionality from our nxopentse package with shared code in there and wrappers for all sorts of functionality, we can have that same code in 30 lines. The main is exactly the same. It's just that those definitions no longer live in our script, but they are part of the external package nxopentse. And to show that it's also working and generates exactly the same output, you can run this one. Well, so exactly the same thing, just a lot less code, a lot simpler code in your use case or when you use it. How do you get NXOpen.UF IntelliSense to work from the Siemens if you're using the Siemens stubs? The easiest is to, again, link to that community page where I have posted all these older versions of the Python stubs. You can copy the UF folder under NXOpen and copy it into the stubs from Siemens in the same directory where all the other stubs are, and then you will get this IntelliSense to work for UF functions. With that caveat, of course, that we still have this modeling issue. So you still have to like double check the documentation, but at least you can, while programming, if you need something, you can quickly search for something like modeling, brep, assemblies. Like we go into assemblies. I think it's assemblies. Yeah, you see ask. I think ask all part occurrence children, ask arrangements in parts. So you can still use ask compositions. So it's still reasonably readable. Sorry. So it's a bit, I think, a bit more practical than the documentation, and then you can use the documentation for the actual implementation and see. So IntelliSense for scrolling, and then that's the full documentation for the actual implementation. And then one last topic, I'm seeing almost at an hour already, is on enumerations in Python. I found that sometimes I'm struggling with them, and I was thinking maybe other people do too. So when we start with an enumeration, this is my main function. Here it's an Simcenter variable. Actually, I had this one as an example, but it's an enumeration. We have all these components. We got from Mises, we've got actual load, we got the membrane stresses, the principal stresses, scalars, torsion, the individual stress components. So principal stresses also. Let's say we want to print von Mises. When we print this, oh yeah, and I love to use F strings, by the way, because then I never have to worry about, I have to put this in cast this to a string first. When I print this, and let's do that, enumeration start. Yes, this one. We will see that von Mises is a variable 18. Von Mises is what I printed in the F string, so that's just plain text, but 18 is actually the value. If you want to give the user feedback, it's not always that practical. There is a function value of. Let me switch to the Siemens IntelliSense files settings. So I will make these. Voila. I might need a little restart for this to work. I think now you should see that when it kicks in. It takes a minute to load because it needs to load all these now. Yeah. I think I need to import. NXOpen CAE. Yeah, there we go. So if you're using sub-modules, sometimes you have to, or quite often you have to import them at the top, and then you get full value again. So there is a function called value of, but it requires an integer again. So I was hoping that if the value of 18, it would actually print von Mises. Let's check. We run it again. We see that it prints 18 again because it actually prints that member type, which is then again 18. When we do this, we will actually get an error again because value of expects a integer, and we'll see here in the error message when we run this that, let me close this, that first parameter is invalid. It's expecting an integer type, but it got NXOpen CSE.result component member type. So it got this, where am I? Here. It's got this result component member type, so which gives an error. So what I found was, this is my a bit of hacky solution, but it works to get at least feedback to the user, is that I created a function called getResultComponentNames. So for an nxopen.cae.result.component, I read the Python dictionary and I generate my own mapping between the integer value and the string value. And then when I have these result components as a dictionary, I do first need to get that member type, because if you remember from this error, it's a result component member type. If I make it a string, it becomes 18 string. If I make it an integer, it becomes 18 the integer, which result component needs. I guess I could have, now that I'm explaining it, I could have made this function a dictionary of string and string, where the first string would be 1, 2, 3, 4. Not too clear. Anyways, this is what it is. So if we now print this to the listing window, we get von Mises. So if we change this to actual, for example, and we run it again, we get the actual value. So if you ever need to get these like result component variables as feedback, or in some way actually the text value and not the number value, this is how you could do it. And I had prepared a final version. So in the first case here, this is an example I took. In this this only works for result components. So this has to be nxopen.cae.result.component. Obviously, there's a lot of enumerations available, and you don't want to write a separate function for each enumeration. So what I did, I generated some intermediate functions, which in essence do the same, but take the class name to as additional information, so that you could call. So this is still the same code we already had, and here is a change that you can actually get enum names, and it takes the name of the component, returns that dictionary, and then gets this one. That's one example. Another example would be to get the enum name from nxopen.cae.result component for Mises. Both of those, this is very close to the previous one I showed with the dictionary and the string. This does the same, but does it in the background, so maybe that's a bit more readable and user-friendly. That's one. And then the other one is actually the other way around. Say I have the string value of the enum and I need the enum object. Then I can resolve it from resolve the enum from string. So I say it is an nxopen.cae.result component with the name actual, which is a which is a string. And we will see that actually returns the correct object. And then we can go backwards again and print out the name. So if we test this one, the final version. Yes, run. A bit big, but it's good. So the 18 again, the error we just saw, the two ways to print von Mises, and actually showing that we have a result component member type object, which is axial, generated from the actual string value to the name of the enum instead of the actual object. These are sometimes things I personally struggle with, and every time I'm thinking, how does this work again? So it helps. I thought maybe it could be interesting that other people struggle with it as well. Yeah, that was it. That's what I wanted to tell on enumerations. And maybe you saw this. I also sometimes use, or often use, often use logging and then add logging handlers so we can get additional text to the window. So if I set this to info, what was it? Info, I think it would actually then update but it would have to double check. I'm not sure if it's going to work. No, it's not working. So with these basic configs and these handlers, you can actually change the format of what you print with like debug the name of the error and the function and the module, and also the date and time when it was generated. That's it, I think. Also, going back to my presentation to see if I covered everything. Yes, go get NX enum name and print the string value instead of the integer for enumerations. Just some last thing. I did that last time. I can do that again. If people are still interested, I have a beginner course on NXOpen and Python, and you can use this coupon, virtual event MAR26, to get the current lowest price on Udemy. And it's not valid till November. It will be valid till April 12th. Voila, just like that. You can contact me, LinkedIn, you can connect, feel free. And also you can send me an email at nxopen@thescriptingengineer.com. And then at the end, and I think I'll just leave this in all presentation slides, there's some links to information. There's the NX help, where you can find sample NXOpen applications in your install directory. The getting started with NXOpen, NXOpen programmer's guide, NXOpen Python reference guide I just showed earlier. And of course, the forum. If you have any questions, you can't find your solution. There's plenty of people out there, me included, trying to help people out. And then I also have the Udemy course available. And that was it from my side.
So everyone who's on the call, if you haven't been with us before, we'll come back to the Q&A. This link, you can click on it now. It is live to get to the NXOpen forums. That is where the recording will be posted end of day tomorrow. So Eastern time, that's the time zone I'm in, that's when it will be posted. The other announcement is every year Siemens PLM puts on Realize Live. It's a customer event. We have it in the Americas, which will be Detroit this year. We have it in Europe, which will be Amsterdam this year. And we have it in India, which is Bangalore, if I'm even saying that correctly. You can click on those links for more info. Frederik will actually be with us in Detroit, in Americas, and in Amsterdam.
Top question, I think the first one. There's quite a few with 3 votes from Joe Caprario. Navigating the NXOpen documentation to replace find object from recorded journals. That is not always the easiest way to do. But what you will see, and that will be my tip for you, you could see it already. Yeah? If your find object, when you record a journal, you will get something like work parts, dot bodies, dot find object, and then your journal identifier. It's what is it for extrude? Something like this, something in this trend. Obviously, you need to replace this one with your actual body. What you will see is that you can get all bodies returned like this. So the object on which find object works, which is bodies, you could, in a lot of cases, let's say 3/4 maybe of the cases, you can actually get all these items for your bodies. So this gets all the bodies, and then it will be up to you to write code to identify the different bodies in there. That can be on journal identifier, that can be on color, that can be on attributes. Yeah, all sorts of properties, how you could identify that body code-wise. Yeah, hope that gets you a little bit further. But yeah, removing the find object is not always that easy, especially when it comes to more complex structures. Just wanted to get back because I saw I wasn't sharing my screen when I showed the answer to, I think, to Joe on the bodies. So if you do work part.bodies.find object, that's what will typically get recorded. Your work part.bodies, in this case all bodies, that will get you all the bodies in the part, and that find object will be one of them. The trick will then be to identify that specific one, and like I mentioned, colors, size, attributes. I believe attribute is actually quite a robust way of doing it. Or if it's only one, add the body. But the more complex the objects become, sometimes it's a bit trickier to identify them. The first one, the last one, that kind of thing. From Joe, example code for saving and opening in Teamcenter. I think there on the forum, if you go to the NXOpen forum, you will find some example code how to open and close Teamcenter files. Yes, I think that was answered in the tips and tricks, the U functions or UF functions. So if you want to add them to the Siemens stub files support, you can go to the post from me where I distributed all the stub files for like NX12, NX23, and you can take that UF folder there and add it into the Siemens files, and then it should work. If you have Joe again, most efficient way to get objects in CAT and CAE by name. If you have named the object, you can just do a list comprehension on the object.name property. Compare those, and that should give you your name. Be careful there that if you have things with multiple names, list comprehension will give you all them back. If you then take the first one, that might not always be what you want. The TSC library is a separate library. It's open source and available on GitHub. And to use it, you need to point it. You need to point the Nix to use your external interpreter. I think next session would probably be a good idea to discuss the external interpreter and also then how you can use NXOpen TSC, but also, for example, NumPy, Pandas, HTTP requests, and so on. Would have to question from Wasim on fem part, IPart, merging of and edges and so on. Doing things on geometry and especially edges is not that always that easy. So we'd have to look into detail on how that would work. Question from Roberto Puzzu. Run the entire analysis from cat generation to fem results via batch. Yes, in a Linux environment, yes, I would say, given you will need the additional license. Only thing which doesn't work is is graphical things. But I think even for Simcenter 3D, you can enable the headless graphics, and then you can still make screenshots. But I have this full setup. What you're describing is available as a course. My first course I ever did for Simcenter in C#. As not Python. If you want to use Python, all that functionality isn't available in NXOpen TSC. So I didn't really go through it. Let me share my screen again. So NXOpen TSC. I have a CAE dot pre-processing, for example. jump to the source code. So in nxopentse pre-processing, there is things to create mesh collectives, create nodes, nodal constraints, nodal environments, solver sets, loads, subcases, constraints, solutions, solution properties, creating displacement fields, linear accelerations, getting all FE elements, add related node and FE elements to groups, copy groups to sim parts, create forces on groups, and so on. That's like all in pre-processing. If we then go to post-processing, there you can load the results, get all the result types, delete companion results, check post inputs, get the result names, combine the results, result A plus B divided by C, exporting results to universal file, enveloping results, get a maximum von Mises over all your use cases, enveloping solutions, get specific nodal values for specific reporting, submodel functionality, that's all in there. So you can, with these functions, depending a bit on what your analysis exactly looks like, but you can build an entire structural analysis from mesh. So you would still do the meshing by hand, but from then on onwards, loads, boundary conditions, solving, post-processing, and also, I have it somewhere else, I think. Let's see. It's called results display is actually the code in which you can automatically generate screenshots. So in essence, you give it an input file with the screenshot definitions it needs to generate, and it will generate then 100 or 1,000 if you want. And that's the one which still needs some graphical inputs, and for that one you will have to use enable headless graphics. So yeah, Roberto, I'm not sure if you're still here, but very long explanation on Simcenter. Joe again. Joe is very active in questions. So when you generate a new block styler or make modifications to the block styler, your code gets overwritten. I just leave it there, and what I do is I keep that in a separate file, and I just copy over the differences, because you start building code in your block styler anyways, so it's really hard to keep those changes. No, Design Center X, very little experience. I believe initially NXOpen was also not available there. I'm not sure if it's currently already is. Question from Andrew. Block UI dialogues in headless mode. Those are a bit contradictory. What I tend to do is I tend to write my code as functions and then use those functions, call those functions in the UI dialogues, which allows me to distinguish between running headless or actually running with a dialogue, and it's an easier switch between the two. Kenneth gave some actions in using open sample applications. Thank you. That's also in the presentation slides in the link. This is question from Pablo. If we can use C# applications. I think that's technically possible, but it goes way beyond your standard use case. Yes, forced to go and press the journal. I think batch would be already a very intermediate solution if you can get that to run. Yes, and then Louis Vargas, print messages to the console in Python. The listing window will actually write to your listing window and also to the console defaultly. Yeah, that's it, I think. I think for newer questions, we will have to look through them and for the next Q&A session.
Until then, we'll see you guys in the forums, or we'll see you on our next call.
Okay, right. Thank you.
Yeah.
Thank you
Thanks,
for everybody for
everyone.
attention, for joining, and hope to see you next time.
Bye-bye.
Bye-bye.